Shapes and consecutive integers. So in this set of notes, we're going to focus on two types of word problems. Now, all these word problems are going to be done very, very similar, and that's what you have to focus on when you're doing word problems. And that's the whole key to being able to do word problems, is to pick out what kind of word problem it is. And once you pick out what kind of word problem it is, you're going to set them all up very, very similar, okay? So the first type of word problem we're going to set up is a consecutive integer word problem. Now, a consecutive integer means it's one integer right after another, like 1, 2, 3. Those are consecutive integers. Or 14, 15, 16. Those are consecutive integers, okay? So find two consecutive positive integers. So we don't know what the first integer is, and that's what we're trying to figure out. So we will call that first integer x. Now, if you talk about consecutive integers and you don't know what they are, so think about the two integers 4 and 5 for a second, okay? So we don't know what these are. I'm just making up two numbers, 4 and 5. Think about if 4 was x, think about how you got from 4 to 5. Well, you added 1. So if 4 is represented by x, 5 would be represented by x plus 1, okay? So our two consecutive integers are x and x plus 1, okay? So we don't know what they are. All right, so let's go back to the problem. All right, so find two consecutive positive integers such that the square of the first is decreased by 17. So the square of the first, so the square, decreased by 17, so minus 17, equals 4 times the second. So 4 times the second one. And so now we have our problem set up, and we just solve for x, okay? So what I'm going to do is I'm going to go over here, and I will distribute over here on the right side. So I have 4x plus 4. I'll bring down x squared minus 17. And what I'll do is I'm just going to move everything over to the left side. So I have x squared minus 4x. If I subtract this 4 here from the 17, I'm going to combine those terms. I'll have minus 21 equals 0. Okay? Now, from here, there's several different ways. This is quadratic. There's several different ways I could solve this. I can factor it. I can do quadratic formula. I could graph it on Desmos. That's one of our quicker ways that we can do that. So if I want to go to Desmos here and graph this, if I want to do x squared minus 4x minus 21, and my two solutions are going to be negative 3. Let's see, x squared minus 4x minus 21. So I got negative 3 and 7. Okay, so those are my two solutions. Now, think about what makes sense here. So those are my two solutions for the problem. So x equals negative 3 and 7, okay? Well, what makes sense to be x? Find two consecutive positive integers. So I want to use the 7. That's what I want to use. So my two numbers I would want to use, x would be 7 and then 8, because 7 and 8, two consecutive integers, so 7 and 8 would be my two numbers. I wouldn't want to use negative 3 because that's negative, it's not positive, okay? All right, so next problem. The ages of 3 family children can be expressed as consecutive integers. So this time I've got 3 consecutive integers. So that would be x, x plus 1, x plus 2. Those are the, I didn't write down 2. X plus 2. The square of the age of the youngest child. So the square of the age of the youngest child is 4 more than 8 times the age of the oldest child. So we take the oldest child, so that's going to be equal to the oldest child, and it's 8 times the oldest child, and it's 4 more as well. Okay, so that's how we set that up. Now, it doesn't say anything about the middle child, but we'll use that. We'll figure out what the middle child is once we solve this. Okay, so let's solve. Let's simplify here. So we'll get 8x plus 16 plus 4, and that'll be x squared equals 8x plus 20. And then if we move everything to one side, we'll get x squared minus 8x minus 20. And then if I want to go to Desmos here, I can just plug this in on Desmos and find my intersection. So I've got x squared minus 8x minus 20. I use those intersections. So once again, I've got a negative answer, a -2. Well, it doesn't make sense for a kid to be -2 years old. We're not going to say that. And we've got 10 years old. So let's just write down the 10. So we know x is 10. The youngest kid is 10 because x represents 10. So the kids are 10, 11, and 12 years old. All right. Find 3 consecutive odd integers. Now, it's switching up odd integers. So think about odd integers like 3, 5, 7, 9, 11, and so on, okay? So if we write down a few odd integers, let's just write these down over here real quick. So like 3, 5, and 7, okay? So those are some odd integers. Well, if 3 is x, think about how you get from 3 to 5. You added 2, okay? Because to get from 3 to 5, you had to add 2 to get to 5. Well, think about how you got from 3 to 7. You added, so think about, well, how many are you adding to 3 to get to 7? You added 4 to get to that number, okay? So this is what you're going to be doing. These are the things that you're going to be using here to set up your problem. Now, we don't know what they are. I just made up, 3 odd numbers, but that's what you're going to be using to set up your problem, okay? So we got x plus 2, x plus 4. All right, such that the square of the first, so the square of the first increase the product of the other 2 is 224. So the product of the other 2, which means we're going to multiply, and it increased, so that's why we added right there, is equal. So anytime you see is, that equals 224. Okay? All right. So let's simplify this here. So the first thing we need to do is we need to FOIL right here. All right, so x times x is x squared. X times 4 is 4x. 2 times x is 2x. And 2 times 4 is 8. And then, of course, I bring down that x squared. So x squared plus x squared is 2x squared. 4x plus 2x is 6x. And then I am going to go ahead and subtract 224 from 8. And that's going to give me negative 216. Okay, so here is my quadratic. And I'm going to enter this into Desmos. All right, so here's my equation. I have 2x squared plus 6x minus 216. Okay, now once again, there's one on the negative side, but it doesn't make any sense. We're not gonna worry about the negative number. We're worrying about we want the positive. Okay, because a negative number thrown in there is not going to give us a positive 224. We want the positive 9, okay? A negative 12, so negative 12, and plus the negative 12, that's an even number, okay? So that's how we know it's not negative 12, because it's not an odd. It says find 3 consecutive odd integers, so negative 12 is not going to work anyway, so we want the 9. The 9 is the odd number. So it's going to be 9, 11, and 13. Those are our 3 consecutive odd integers. Okay, so those are some consecutive odd integer problems. Now let's get into shapes, because the title in this was shapes and consecutive integers. So let's get into shapes. That's our other type of word problem that we're going to focus on. So Joe's rectangular garden is 6 meters long and 4 meters wide. Now I always like to draw pictures because pictures help me. So we got our rectangular garden, 6 meters long and 4 meters wide. He wishes to double the area. Now we're already talking about the area. So if we're going to double the area, we need to figure out the area of this garden. So 6 times 4 is 24. So it's 24 meters squared. So our new area, if we're going to double it, our new area is going to be 48 meters squared by increasing its length and width by the same amount. Okay, so if we're going to be increasing by the same amount, what we're going to do, we don't know what we're adding to it, but we know that we are going to add x to both sides. Okay, all right, so this is how we've set up. So find the number of meters which each dimension must be increased. So if we're talking about area, we're doing length times width here. So we would do 4 plus x times 6 plus x equals 48, okay? So what we can do here is if we simplify this, we got 6 times 4 is, we got 24, and then 4 times x is 4x, 6 times x is 6x, and x times x is x squared equals 48. All right, so if I subtract 48 from the 24 and go ahead and move it over, I've got negative 24 plus 10x plus x squared. So I can go to Desmos once again and use that. So negative 24 plus 10x plus x squared. Okay, once again, there's a negative. It doesn't make sense to have a length of negative 12. We've got a length of 2. Our x is 2. Okay, so our x is 2. Now our x is 2. That's what our x is, okay? Our x value is 2. That's what we just found. Now the question is asking, find the number of meters by which each dimension must be increased. So it's not actually asking for the new dimensions. So it must be increased by 2. And our new dimensions would actually be 8 and 6, which makes sense because 6 times 8 is 48. Okay. All right, so our next problem here in a trapezoid. Okay, so let's draw a trapezoid. And I'm going to do a simple trapezoid here. I'm going to do a trapezoid like this. Okay. The smaller base is 3 more than the height. Okay, so I don't know what my height is. The smaller base is 3 more than the height. And the larger base is 5 less than 3 times the height. Okay, so it's 5 less. Remember, it's 5 less. I don't know if you've ever heard this little phrase, but when it's less, it comes last. Okay, less is last. So you put the minus 5 at the end, then 3 times the height. Okay. So think back here, area of a trapezoid. I don't know if you remember this or not. It's not used a lot, but here's area of a trapezoid. It's 1/2 times height, base 1 plus base 2. There's your area of a trapezoid. So we're just going to fill that in. And it does tell us that the area is 45 square centimeters. So I just plug in here. So I got 45 equals 1/2. I don't know what my height is. My base is 3 plus h, and my bottom base is 3h minus 5. And now I'm just going to simplify. I'm going to combine like terms here. So I've got 45 equals 1/2 h. Let's see here. If I combine 3 minus 5 is going to be a negative 2 plus 4h. And then if I multiply, I'm going to distribute the 1/2 here. So 1/2 times -2 is going to be a -h. And 1/2 h times 4h is going to be a positive 2h squared. So I'm going to move that 45 to the other side. Let's see, let's go over here where I got a little more room. And I'm going to reorder. I'm going to put my 2h squared first, minus h, and if I move 45 over, it's going to become negative. And I actually should put a 0 over there because everything's going to the right side. Okay, so here's my equation I'm going to type in on Desmos. Remember, I just like to use x's instead of putting in any other variable. So I have 2x squared minus x minus 45. Okay, once again, we're always using the positive value. You're not ever going to use the negative. So 5 is our value. Okay, so h equals 5. And it is asking for the height. And so that is our answer. H is 5. So be careful. Just pay attention to what it is asking for. Our h is 5 here. If it did want to know the base, you would do 3 times 5 minus 5. So that would be a 10. And if it wanted to know this, we would do 3 plus 5, which would give us an 8 for our top base right there. Okay. Next one on number 6. The length of one side of a square is tripled. Okay, so we're talking about a square here. All right, length of one side of a square is tripled. And the length of an adjacent side is increased by 10. Okay, so we're obviously not a square anymore. The resulting rectangle has an area that is 6 times the area of the original square. So our original obviously was x times x, so it would be x squared. And so the original, so the new one would be 6x squared, okay, because it's 6 times. And now we do 3x times x plus 10, because we would multiply this one and this one, because you would do length times width, okay? So now we just simplify and we'll get everything on one side so we can plug it into Desmos. Okay, so I have, let's go back to blue here. 6x squared would distribute 3x squared plus 30x. And now I just want to, if I just move this 6x squared to the other side, so I get 0 equals negative 3x squared plus 30x. So negative 3x squared plus 30x. Okay, so obviously I've got 1 on 0. That's not going to do us any good. And I get a value of 10. So our x is 10. Let's see what it's asking for. Find the lengths of the sides of the original square. So the lengths of the original sides is just 10. Okay, find the length of the rectangle. Okay, so we have a rectangle, so I'm going to draw out a rectangle. 7 units more than the width. Okay, so I don't know what my width was, but the length is 7 units more. So I add 7 to it. Then if the width is doubled and the length is increased by 2 and the area is increased by 42 square units, find the dimensions of the original rectangle. Okay, so then we've got this other rectangle over here. If the width is doubled, okay, and the length is increased by 2, well, if you increase that by 2, the 7 becomes a 9, okay, because if we add 2 to that, that's just going to become a 9. Okay, so what we want to do here is you've got the x, the original area, x times x plus 7, which is going to give you x squared plus 7x, okay? And let's see here. And then your area over here, you've got 2x times x plus 9. So that's going to be 2x squared plus 18x. All right. And so then what it's saying, the area is increased by 42 square units. Okay. The width is doubled and the length is increased. The area is increased by 42 square units. So what we want to do here is we're going to take this, x squared plus 7x, and then it's increased. That's what it's talking about, is increased by 42 square units. And then we set it equal to 2x squared plus 18x. Okay. And now what we're going to do is we're going to combine everything on one side. We're just going to move everything on one side. Okay. So I am going to move everything over to the right, I believe. Okay. All right. And I'm going to move 7x over here. All right. And so that's going to give me x squared plus 11x. And then minus 42, because I would also subtract 42. Because there's nothing over here to subtract 42 from. Okay. And that's all equal to 0. So this is the equation I'm going to type in on Desmos. Okay, so I have x squared plus 11x minus 42. And obviously we're not using negatives, we're just using the positive value. So our x value is 3. Okay, so x equals 3. All right, so let's figure out what it's asked for. Find the dimensions of the original rectangle. So x equals 3. And then this, if this was 3 plus 7, that equals 10. So my final answer would be 3 by 10. It wants the original dimensions. Find the dimensions. So you got to give 3 by 10. You can't just circle 3 and let that be it. Okay. Last problem. The side of one square, so if it's a square, you know that the sides are even, is 2 centimeters longer than the side of the second square. Okay, so we have one square that's a little bit bigger than the other. So 2 centimeters longer. So if they're squares, we know that they're the same. If the sum of their areas is 100 centimeters, find the length of the side of each square. Okay, so the area of this one is x squared, because remember you multiply length times width. This one, this area, you would multiply those two together. So x times x is x squared. Then x times 2 is 2x. 2x times x, or 2 times x is 2x, and 2 times 2 is 4. So we get x squared plus 4x plus 4. So this is this area. Okay, so it says the sum of their areas. So we're going to add these two things together. So x squared plus x squared plus 4x plus 4 equals 100. Okay, so if I combine like terms, I'll get 2x squared plus 4x. I'm going to subtract 100 to get everything on one side, which is going to give me negative 96. And then that equals 0. So this is what I'm going to type into Desmos. So I've got 2x squared plus 4x minus 96. So we're not using the negative side. We just want the positive. My x is 6. Okay, x is 6. Okay, and it's asking the length of the side of each square. Okay, so 6 and 6. And if that was 6, that means this is 8 and 8. Okay, so for the smaller square was 6, and the larger square would be 8.